So good morning everyone. So today we are going to see another application of two-dimensional arrays, that is matrix multiplication. So you know that matrix is the element which can be stored in the form of rows and columns. For this particular approach, we will be using a two-dimensional array because we are using matrix multiplication. So if you take this matrix multiplication examples, I hope so everyone can recall their school days how they used to perform matrix multiplication. So for matrix multiplication, you require two matrices, that is matrix A and matrix B, and that as an input, and we require the result to be stored in another matrix. So in this case, we have taken a matrix of 2 cross 2, both A and B. It's not necessary that to multiply always you should take a square matrix. You can perform matrix multiplication on the matrix which is other than square also. So what is square matrix? A matrix which contains same number of rows and columns. So keep one thing in your mind, it can be performed on others also, not only square matrix. So here we have a matrix A of 2 cross 2 order and matrix B of 2 cross 2. So what is important here is, before multiplication, all the matrix cannot be multiplied. There is a constraint. So we will see that, look into that constraint later. So all you know that how the matrix multiplication works. So a row of one matrix will be multiplied with column of another matrix. Okay. And similarly, row of the second matrix will also be multiplied with column of another matrix. So this is how the matrix multiplication happens. So you can see that first 1 into 5. So we are taking row here, row with 5 and 2 into 0. So the row with column. Okay. Then again, we have finished only first row with first column, then first row with second column, then second row with first column, and second row with second column. So this is how we perform the matrix multiplication. So before you start entering the elements inside the matrix, first you should enter the number of rows and columns to create the matrix. Okay, you need to create a two-dimensional matrix. Of what order? So this is a 2 cross 2 matrix. So what will be the number of rows and columns? So the number of rows and columns of matrix A will be 2 comma 2, and it will be saved in m comma n. So let us take the variables as m comma n to store number of rows and columns of A, or order of matrix we can say. And matrix B can be saved in variables P and Q, and P and Q act as number of rows and columns of matrix B. Okay, so we entered input matrix order. So for an output matrix, you need not enter the order because it is calculated based on inputs. So how does it calculate? So if you need to do a multiplication, then there is a compatibility which we need to check. The compatibility is whether the matrix multiplication can be performed or not. So if you see here, the compatibility can be checked based on the orders of two matrices. That is, the column of one matrix should be equal to number of rows of another matrix. That is, n should be equal to p. If n is equal to p, then only you can perform matrix multiplication. Suppose you think that I have taken a 2 cross 2 matrix for matrix A and 3 cross 2 matrix for matrix B, then matrix multiplication cannot be performed because number of column is 2 in matrix A and number of rows in matrix B is 3. So they are not equal. So this cannot be used to perform matrix multiplication. Whereas if you have 3 cross 2 as a matrix B, and if you have matrix A as 2 cross 3, then matrix multiplication can be performed because n value is equal to p value. Okay, so that is what is the first step you need to think now, whether it is compatible for multiplication or not. Okay, so it's 2 cross 2, then there is no worry because n is equal to p, that is number of columns of one matrix is equal to number of rows of another matrix. And next, if these two are equal, the resultant matrix, so what is the resultant matrix? C. If n and p are equal, the resultant matrix will get its order from the input matrix only. If they are equal, the resultant matrix order will be m cross q. Okay, that is m cross q. In this case, it will be 2 cross 2 only. Okay, so keep that in your mind. Now let us go into the program. So m and pq are the variables which is used to read the order of the matrix. So we read order of the matrix A first. This is how, using printf and scanf. And next we read the order of second matrix that is stored in P and Q. So what will be the values of m and n and P and Q according to this example? All are 2 cross 2, so it will be all 2. So M, N, P, Q all are read as 2. Now you need to create a two-dimensional array. So how to declare an array with size of 2 cross 2? So we are declaring int a of m comma n. M and n are the order of a, so we are specifying m comma n. Int b of p comma q, that is 2 comma 2 only, because p and q are the order of matrix p. And finally c, it can be fetched by m cross q, so we are saying int c of m cross q. So after declaring this, now your array is ready to store the element. If it is 2 cross 2 matrix, then you can store at most how many elements? 4 elements. And how much size does this reserve? 4 into size of integer. What is size of integer? Size of integer is 4 bytes. So 4 into 4, 16 bytes will be reserved for each matrix, and each block will take 4 out of it. Okay. So since it's an integer array. And next, first we check the compatibility. So how do you check the compatibility? If n is not equal to p, that means if n is not equal to p, in this case it is equal. If you imagine that m is not equal to p, then you can't perform matrix multiplication. So you have to inform the user there itself that it cannot be performed to do matrix multiplication, because the order is not valid. It's an invalid order. If in this case, what is n value? 2. What is p value? 2. Is it 2 not equal to 2? It is false. That means it can perform matrix multiplication if it is equal. Here is saying not equal means you cannot perform. So this is false. So it will go to else case. So in else case, so your array is ready. Now you should start entering elements one by one. 1, 2, 3, 4, so on. You need to start entering the elements. So next, what you need to do is keep one thing in your mind. You need to enter elements one by one. And here in matrix format, the elements will be entered in the form of row and column wise. Row and column wise. First, it completes first row, first column, first row, second column. Next, second row, first column, second row, second column. So to enter them into an array, since it's a two-dimensional array, we have already studied, we require the help of two loops. The I loop will be controlling number of rows and J loop will be controlling number of columns. I need not tell much about this. If you don't know how to read the array in a two-dimensional, you can refer to the topic what we have mentioned in two-dimensional array. So there you can clearly see how a two-dimensional array can be read. So I and J is going to be reading the row and column value and using a scanf statement. So first it begins with first row and it completes all the columns of first row. How many columns? 2 columns. Then it will go to the second row and finish all the 2 columns of second row. And then it comes out of this loop because it is only 2 rows and 2 columns. Once this has been read, similarly, you need to read matrix B. So you read matrix A. That means you have entered now 1, 2, 3, 4. Next, you have to enter 5, 6, 0, 7. For that, you go and read the second array using printf. Okay. So enter the element. How many element? 4 element. Why? Because we are printing p cross q. That is, for if it is 2 cross 2 matrix, you are telling the user to enter 4 elements. So again, same for loop. The only thing what changes here is we read all the element in matrix A. Here we are reading it in matrix P. So once A and B has been computed, then you can perform the product. Okay. How do you compute the product? So this is very important thing. So you know that basically the order of product is what? M cross Q. So the number of rows will be M to calculate product and number of columns will be Q. So if you carefully see here, this for loop will run up to M and this for loop will run up to Q. Okay. So why is that? Because if you see product B, matrix B's order was P and Q. So I was running up to P and J was running up to Q. And for matrix A, the order was M and N. Okay, so I used to run up to M and J used to run up to N. So now in this case, we will just start one by one and see how this particular thing works. So now keep one thing in your mind. When you perform, which is the first element which you have fetched from matrix A? From matrix A, you fetch 0, 0, and that is multiplied with matrix B's 0, 0. So that means 1 into 5 has been performed. 1 into 5 plus we are going to perform 2 into 0. That is first row's first element with second row's first element, second row first element with matrix B. So that means we need to perform row into column. So this, there are nested loops. I will be controlling the row, J will be controlling the loop, column, and K is a variable which helps you to multiply between row and column. Okay, row versus column you need to multiply. And I am going to take another matrix here, which will be all initialized to 0. So this will not initially get the output. All this matrix C will be 0. When will you get this 5, 20, 15, 46 after computing the product? Okay, so let us see how it does. So initial value of I is 0. I hope you understood why it goes to M and Q, because I value, the row number of rows for resultant matrix will be M cross Q. So C of I of J, that is the first element when you multiply will be going into C of I. What is I? 0. C of J, that is 0. It will be initialized to 0. So initially it will be 0. Now we are taking one more loop K. So there are three nested loops. So in three nested loop, the first loop which will complete will be K, and the next loop which will be completing will be J, and the next loop which will be completing will be I. Okay, so now in K, so where are you supposed to store first element, that is 5? This element, when you multiplied 1 into 5 plus 2 into 0, it should be saved as a first element. So which is the first element in C matrix? 0 comma 0, that is C of 0 comma 0 we have to compute. So look at this, C of 0 comma 0 before computation is made to 0 because we don't want any junk values in those element. We can't declare it as it is, it will have some junk value, so we initialized it to 0. So when the kth loop becomes, this is where the multiplication happens. So carefully observe here, initial value of k is 0. So let me write the line below. So what is the line you are writing? C of 0 comma 0, that is I, how ij value is 0 comma 0, is equal to C of 0 comma 0. What is the current value of C of 0 comma 0? It is 0. We have initialized it to 0, plus A of, what is I value? 0 comma I value is 0, K value is 0, into B of K value is 0 and J value is 0. So carefully observe, this is going to multiply the first row element into, that is first row element 1 into 5. It is going to do 1 into 5. Carefully observe. What is the value of A of 0 comma 0? What is there in A of 0 comma 0? 1. So let me let me just calculate this. Okay, equal to 0, because C of 0 comma 0, what you have in C of 0 comma 0 is 0, plus what is there in A of 0 comma 0. So look, go to the matrix A and see what is there in 0 comma 0. It is 1. So look at carefully this thing, 1 into what is there in B of 0 comma 0. In B of 0 comma 0 we have 5. So this done 1 into 5. Okay, 1 into 5 is 5. So if you calculate this, 0 plus 1 into 5 is 5. Okay, 5 plus 0 it will be, and where it will be stored in C of 0 comma 0. So let us see C of 0 comma 0. It's right now it is storing 5, but we cannot conclude by just calculating 1 into 5. Just we have done first row element with second matrix first row element, and now we have to compute 2 into 0. So now look at this, what happens to find out 2 into 0. I and j remains 0 comma 0 only, because now again we are in case loop. K should run for n times. Okay, so what is n? N is 2, so it will run up to 0 and 1 because 2 columns it has to calculate. So what is the current value of C of 0 comma 0? Current C of I comma j means C of 0 comma 0. So it will be C of 0 comma 0. Now k has been changed. So look at this, A of I comma k, it will be 0 comma 1, and B of k comma j, it will be B of 1 comma 0. So that means first row's first element with second row's first row's second element with second matrix, sorry, come again, first matrix, second element, with second matrix, second row's first element. That means we had in C of 0 comma 0, what do you have? 5. It has been saved here. C of 0 comma 0 is 5. Now that for that 5, so that means, so 1 into 5 is 5. For that 5, you have to add 2 into 0. That's what is happening now here. 5 plus, so what is there in 0 comma 1? In 0 comma 1 of A matrix, you have 2. So carefully observe, we are going to put 2 into, in B of 1 comma 0. What do you have in B of 1 comma 0? In B of 1 comma 0, we have 0. So it's going to multiply 5 plus 2 into 0. So what is 5 plus 2 into 0? 2 into 0 is 0 only. Okay, 5 plus 0 is 5. So that 5 will be now added as a first element of C matrix. Okay, now we completed first row. We completed first row's first element of C matrix. Now what happens? K will be terminated. If it becomes 2, K will be terminated. Okay, because K is not less than 2. Now it will go to the outer loop of this. Now J will become 1. So that means which column now you need to calculate? You need to calculate 0 comma 1. We calculated 0 comma 0 of C. Now we have to calculate C of 0 comma 1. So now we can see J becomes 1. And now this will also be C of 0 comma 1. It will be always initialized to 0 comma 1 first. Okay, and then I comma K will be 0 comma 1, and this will be also 0 comma. So I will out of K will be 0 comma 0, because K value is 0 now. When it starts, K value will be 0. So only J value has been changed. So now initially C of 0 comma 1 is going to be 0, because we initialize here current J, C of I J. Okay, so initially it will be 0 plus, what is there in A of 0 comma 0? We have 1. So again 1 into 6 has to be multiplied with 2 into 7. Now we are going to multiply first 1 into 6. Let us see. So 1 has been, A of 0 comma 0 is 1 into, what is there in B of 0 comma 1? B of 0 comma 1, you have 6. So we did 1 into 6. And this result will be saved in 0 comma 1. Okay, so for time being. So what is the answer? Answer is 6. Okay, now when K becomes 1, look at the changes. This is the one which makes rows and columns shift. This remains same, 0 comma 1, because it's including I of J. Okay, I of K. Now I is 0 and K is 1. And K is 1. So it will be B of 1 comma 1. So 0 comma 1, the answer is 6, plus, previously we calculated 6, plus A of 0 comma 1. What is A of 0 comma 1? In A of 0 comma 1, we have 2. Okay, now it will do 2 into 7. Look at this, 2 into, what is there in B of 1 comma 1? In B of 1 comma 1, let us see what you have. B of 1 comma 1, we have 7. Okay, so 2 into 7. So 6 plus 2 into 7, it will be 20. It will be 20 will be saved in C of 0 comma 1. So look at this. In C of 0 comma 1, we have 20. So similarly, next we have to find out C of 1 comma 0 and C of 1 comma 1. So this is how it goes to calculate all the elements of an array. And this is how you calculate the product. Okay, so to calculate product, we require ij to compute rows and k for to computing the columns. Okay, so this is how it computes a product. Now what you need to do now, where is the result in the matrix C? So now let us print matrix by matrix. First we should print matrix A. So like how you read matrix A first, similarly you need to print matrix A. So how do you print? Two for loops and a printf statement. To read, two for loops, and to scanf statement. To print, it is two for loops and one printf statement. So we print what are the elements of matrix A. So keep in your mind, you know how the matrix will be. First, after printing first two rows, it will go to the new line. So that is why you can see that in while printing matrix A, we have a new line character here. So that means when it prints the first row element, before going into the second row, it will have a new line character. Then it will go to the I loop and increment the next row. Similarly, next print matrix B. So it prints the matrix B. And finally, where is the result? Result is in matrix C. So print matrix C. Okay. So first print matrix A, next matrix B, and finally you print matrix C. So this is how matrix A, matrix B, and matrix C will be printed. And only thing while printing you should be very careful is their orders. For matrix A, the order is M comma N. For matrix B, the order is P comma Q. And for matrix C, it is M comma Q. So this is what is the matrix multiplication program. So I tell you all, execute this program once and analyze this step by step. So you will find out how the matrix multiplication is been computed. I hope so you have understood this topic. We will meet in the next session. Thank you.